Okay, welcome everybody. This is section 9.2, series and convergence. 9.1 was kind of similar. I'm talking about converging sequences. So let's see what we have here for 9.2. An infinite series or infinite sequence. Where you're just adding up the numbers. Here, this is a summation symbol. Just want to make sure everybody's got that. You put a 1 in there, you get whatever the first one is, and you add it to the n equals 2, n equals 3, and so on, all the way to n equals n. This is the right here. It goes all the way to infinity. Add them all up and see what you get. I don't think there's anything else that it talks about here yet. This is all just from algebra. We learned about a lot of this in algebra, and we did some of it in Cal 1. Here's another way of saying to add up the summation of the series. You're just going to add, n equals 1, plug it in, find the answer, n equals 2, plug it in, find the answer, and so on. If the series, it says here, if the summation converges, then the limit of S is called the sum of the series. So, I mean, it's really, it's almost the semantics here, but it says if the sequence of partial sums converges, then the series converges. The limit of the series is the sum of the series, and if Sn diverges, then the series diverges. If the summation diverges, then the series will diverge. That really doesn't mean much until we do examples and stuff.
It's like saying the black cat is black.
Yeah, exactly. So if we look at this, why is everything off? This is weird. Let me go up. Yeah, it's hard for me to go from writing on my pencil to writing to going to the next slide. It doesn't let me do that. So if we just look at this series here, you plug n starts at 1. You plug 1 in there, you get 1/2. You plug 2 in here. N equals 2 is the next one. 2 squared is 4. You get 1/4. You plug 3 into the next one. 2 to the third, you end up with 1/8, and so on and so on. And what we want to do, if it lets me, there we go. And then you can go all the way. You can go all the way to the very end. And here, you're just saying whatever n is, you say 100, the 100 one would be 2 to the 100, 1,000, 2 to the 1,000. And then if you look at it, they're showing you that this summation is the same as this. So you can find, rather than trying to add all these up, you can use this as your answer, as your summation. And if you look at that, we're talking about if you just added up the first 3, from n equals 1 to 3. If you added up the first 3, just the first 3, you would get 7/8. 1/2 plus 1/4 plus 1/8. If you added up the first 2, you would get 1/2 plus 1/4 equals 3/4. If you look at this pattern, it starts off with 1/2, 3/4, 7/8. The top number is always 1 less than the bottom number. The top number is always 1 less than the bottom number, and so on and so on. So if you continued on, with S4, you would have 1/2 plus 1/4 plus 1/8, then plus 1/2 to the 4th power, which is 16. And then when you added those up, you would get, if you put 4 in there, you'd get 15/16. You see, if you put 4 in here, you get 16 minus 1 is 15. And on the bottom, you get 16. So the top number is in this sequence, in this series, the top number will always be 1 less than the bottom number. And another way, they're just showing you another way of writing the entire sum for as many numbers if you want. If you wanted to write the sum for the first 10 numbers from 1 to 10, all you had to do is put a 10 in here and a 10 in here, and you would get the answer to the sum. Now, another way of also looking at this, where is this sum leading to? It's going to here, it's going to here. And the next one was 15/16. Where does it look like this sum is going? If you look at this, each number, if the top is going to be less than the bottom, the next number, I think, would be 32 on the bottom. So we'd have 31. If you look at this, the sum is getting closer and closer to 1. It's getting closer. Do you see? This is close to 1, 7/8. This is even closer to 1, 15/16. This is even closer. So each next sum, if you added them all up, sum from 1 to 10, you're getting closer to 1. So if you add up all the sums to infinity, you'd virtually pretty much have 2 to the infinity over 2 to the infinity. This minus 1 is insignificant when you're talking about infinity. So 2 over infinity divided by 2 over infinity approaches 1. It's approaching 1 and getting really close to 1, especially when you're in numbers as high as infinity. So you can see where that limit is going to. It's going to 1. And it should tell us that, I think, on the next page. Yes, it does tell us that on the next page. So it follows, the series converges because it does approach a limit and a single number, and it converges to 1. Let's see what else these PowerPoints have to do. Once again, these are partial sums, and a lot of times what you're going to do is trying to figure out a formula for the sum. Rather than trying to add them all up, you can look at a formula for the sum here. They showed it, if n is 1, you end up with 1. Put a 1 here, you minus 1 over 1 plus 1 is 2. So this is when n equals 1. This is when n equals 2. This is when n equals 3. If you have n equals 4, you would have 1/4 minus 1 over 5. 4 plus 1 is 1 over 5. If you look at this, this is kind of cool. If you look at this, let me change my color. The minus 1/2 and plus 1/2 will cancel each other out. Minus 1/3 and plus 1/3 will cancel each other out. Minus 1/4 plus 1/4 will cancel out. The only thing that really didn't cancel out was this 1. You see, as you're moving on, and then at some point, if you stop, you're left with something. And that's what this last part is. Do you see? We have the 1 in this, but then you're left with something else. Whatever the n, I mean, if you're asking somebody to sum these up from 1 to 10, then the last term would be 1 minus, this last term that wouldn't cancel out would be a negative 1 over 11. 10 plus 1 is 11. Okay, but when we go to infinity, this becomes a really huge number. Infinity plus 1, 1 over infinity ends up equaling 0. So they want you to see that if you put infinity in here, 1 divided by infinity ends up being 0. So no matter what you do, this summation is going to equal 1. This particular summation will end up equaling 1 because the other things will cancel each other out here. So they want to show you that. So it's always good to see if you can find that formula that we have here for summation. So you can put that in your calculator. I don't know how you put infinity in your calculator, just put a very large number and it'll tell you where it's going to. Or you convert the summation to a formula that will give you the sum depending on what n equals here at the top, what number n goes to. And in this case, these all go to infinity. So if you put infinity into the formula here, this turns to 0. And so the summation equals 1 when you go to infinity. Okay. And it tells you since the limit goes to 1, then the series converges and it's the sum of 1. Now the series of this, where you're just adding 1 an infinite amount of time, you see it's not going to anything. If you add up the first 4, you end up with 4. If you added up the first 10, you'd get 10. If you added up the first 20, you'd get 20. So the series is not converging on anything. It's just getting larger and larger. The series is getting larger and larger. It's going up to infinity. In other words, it doesn't converge. It doesn't have a sum. The sum goes to infinity, so it diverges. So you're never going to a particular number. It doesn't have a limit, and if it doesn't have a limit, it diverges. This is the last example, the previous example we have. They're called telescoping series. In other words, a telescope back in the olden days, those sailors would have those telescopes. And what happens is things like I showed you, things start canceling out. So this telescope actually becomes smaller. This will cancel out with this, and then this will cancel out with this, and then this will cancel out with the next one. And you're left with one thing at the end. You're left with one thing at the end. So that's a telescoping series. And it just shows you, and be careful, look and see that these two will cancel each other out. Then these two will cancel each other out, and so on and so on. So normally that might be the answer depending on what that last term is. And if you plug infinity into that last term, 1 over n plus 1, you plug infinity into there, that goes to 0. So it does converge and go to 1. Once again, they're talking about the telescoping series. You have B, and then this is the extra one that doesn't cancel out until you put another one there. So that it tells you the telescoping series often just equals this. The sum will equal this. And if depending on when you put infinity in here, what that equals. Now, geometric series, once again, we did these in algebra, if you remember. And here, I would write down just a couple of notes, and we'll look at this. I would write that down. I'm going to just write that down myself, just for summation. And the key is the A, R to the N. And R is the key here. R is a ratio. What's another word for ratio? What do they mean when if they say R with a ratio R? What does a ratio mean? why did they say ratio?
Fraction.
Yeah, ratio is a fraction. I don't know why they used ratio, but ratio is a fraction. And in the next slide, it's going to tell you if the fraction is over 1, it means one thing. If the fraction is less than 1, it means another. In this case right here, if you look, this is the same as 1 over 2 to the n power, since we have a 1 there, to the n power. You see, so r in this case is a fraction less than 1. It's a fraction less than 1. And that has some meaning as soon as I hit the next slide. Right here, when we have a fraction, when r is a fraction less than 1, greater than 0, and they're talking about the absolute value. So you can have a negative fraction less than 1 and still be called here. Then we want to write this down. We want to use this formula here, and you will be using that formula on the homework, a over 1 minus r. So you will be using that formula on the homework, and I would write that down. And write that down, that's when r is less than 1. Or the absolute value of r is less than 1. Because you can't use that if r, let's say if r equal 3 over 2, you're not allowed, you cannot use this formula because this is greater than 1. So you can only use this formula when the absolute value of r is less than 1. So we definitely want to write that down. And here's some examples. Once again, you can rewrite this, and they're showing you you're rewriting this 3 to the 1/2. And, let me get my pen. So r equals 1/2. A, remember the formula was that we had to write down was this. R to the n power equals a over 1 minus r. So you can find the sum by a is right here. A is 3, is the number in front of the r. So this would equal a is on top 3, and then 1 minus 1/2. And when you do that, 1 minus 1/2 is 1/2. And you put that in your calculator, you end up with 6. So the summation of this goes to 6. And I think they're going to show that to us. I really should look at these PowerPoints ahead of time. I'm almost certain they're r is 1/2, a is they're showing you the whole process I just did. Yes. And the summation moves towards 6. So you can do that. That works well. That works well when r is less than 1. Once again, the absolute value of r is less than 1. You can find the summation fairly quick just by plugging it into the formula. On the next slide, r is greater than 1. See, r equals 1.5 here. So since r is greater than 1, the series diverges. It doesn't go to any particular number. If you try to add these numbers, I mean, here they show you if you plug 1 into here, or they started with 0, by the way. If you plug 0 into there, you get 1. If you plug 1 into there, you get 3 over 2, plug 2, 9/4. Do you see, it doesn't matter what the next one is, since they're all positive, the next number is going to make the series even larger, when you sum it. And then the next number will make it even larger again. So there's no bound. This series every time you add another number, another in the sequence, it gets larger and larger. In other words, the graph is going up towards infinity. Once again, there's no boundary, so the series diverges. And anytime you have an R greater than 1, like that, the series will diverge. That's a good little thing to write down. Anytime the absolute value of R is greater than 1, and it says or equal to 1, the series will diverge. It doesn't converge on anything. So definitely want to write that down. R greater than or equal to 1, the series diverges. And we're talking about geometric series, a fraction with a power that has a power. That's a geometric series. And here's some properties of infinite series. We can take just a quick look at it. You find the summation of this. You have a constant times your a sub n or whatever you're adding together. You can add up all these summations and get a, and then just multiply it by your constant. Here, if you have two summations that you're plugging the numbers into two different forms, you can find the summation of this, you can find the summation of this, and then add them together. If you're adding them here, you can add them, their final answers at the end. Same way with subtraction. You find this summation, you find this summation, you find their total summations, and you can subtract them. And I'm not even sure if we use those in the homework.
Would it be the same for like division or anything else like that?
No. They would have put that there if you had that. So
Okay.
I'm going to say no. Yeah, you would have had multiplication and division there. So I'm going to say those are not properties of the infinite series. If your summation converges, then your limit will be 0. What else is this? This nth term test for, the limit of the nth term. Oh, if you're looking at a certain term in the series, then it also says if the if a sub n, whatever does not equal. I'm not exactly sure. We'll see what this means when we do one of the homeworks. If the limit of the summation to a certain part, a sub n, does not equal 0, then the limit either equals 0 or it doesn't equal 0. If it equals 0, it converges. If it doesn't equal 0, it diverges. Let's see, no, they have an example here. Once again, for the series to the end, you have this. You can look at this right away. I mean, just start plugging some numbers in there. If you plug 0 in there, you get 2 to the 0 power, which equals 1. If you plug 1 in there, you get 2. If you plug 2 in there, you get 4. This is just an ever increasing you plug 3 in there, you get 8. This is just an ever increasing series. So obviously it's going to diverge. The limit of the nth term is not 0. The limit of the nth term is not 0. Can you tell that right away by plugging in infinity? Oh, yeah, you can. Do you see if I plug infinity straight into here, 2 to the infinity is not 0. It is infinity, so that diverges. And this, if you look here, this is kind of similar to one of these. Let me show you this. 3, how did we do it? X to the third over 2x to the third. We said this limit, since the powers are the same, equals 3 over 2. This is kind of the same situation, because if n is a factorial and n is really large, this 1 is insignificant. So we're just looking, these two will cancel each other out, and the limit will be 1/2. Since the limit is not 0, it's 1/2, the limit equals 1/2, then the series diverges. So that's, I like this. This is kind of cool. It's like that horizontal asymptote almost. When you're talking about really large numbers, this +1 is insignificant, doesn't matter. So these two will just cancel each other out, and your limit goes to 1/2. And once again, if you, to find this, let me just plug infinity in here. 1 over infinity is 0. It goes to 0, so the series converges. Should say that if it lets me. Oh, no, it doesn't necessarily converge. It doesn't, because the limit of the nth term is 0, the nth term test for divergence. Okay, that's the thing. It does not apply. So let me go back. That was the last slide. Let me go back to that for a second. I think I was reading it wrong when I was reading it the first time. Up here, is this the after? And see, this is the nth term test for divergence, not for convergence, just to see if something diverges. So I'm not a big fan of this, because if a sub n converges, then the limit of a sub n equals 0. But the actual divergence test that they're talking about is this. If the limit does not go to 0, then it diverges. And they showed that with this example. This doesn't go to 0, so it diverges. B doesn't go to 0, so it diverges. However, this is just the divergence test. So even though this one goes to 0, the only thing we can say is this does not diverge. So the divergence test doesn't apply here. Since it doesn't diverge, the divergence test does not apply, and we'll look at to see if it converges or diverges. So you can't draw a conclusion using this test. If it goes to 0, it might converge. The only thing we do know is we just can't say it diverges. It could converge, but we can't say it diverges. That's a weird test. And that was the last slide. Let's look at the homework, because I think the homework, there's a couple of cool problems in there, because I turned on the homework just to see how many problems there were. There were a good number of homework problems, and there was 1 or 2 that I kind of liked. Let's get there. Looks like it's going to be a short day again. Oh my, come on. Every time you use this Zoom, it slows everything to a snail's pace. All right, so problem one, you're just plugging the numbers in. You plug n. And you plug where the first one, n equals 1. You plug that in. -5 to the second power, -5 times -5 is 25. You plug a 1 in here, 1 factorial is 1, so you end up with 25. So the next S2 would be your 25 from S1, and then you're plugging 2 in here. -5 to the wait a minute. We start at 1. Oh yeah, you plug 2 in here, then you add the 1 and you get 3. -5 to the third power is a -125. Plug 2 in here, 2 factorial is still 2. So this is what S2 would equal when you 25 minus 125 over 2. They do that here, and you get this. Then you plug S. Then you have these two. Now you're going to do the next one, the third one. And since you have 3 here, 3 plus 1 is 4. -5 to an even power ends up being positive 625. And then you put 3 factorial 6. 3 times 2 times 1. And so on and so on. So if you look at this, this ends up being this number when you add it together. This ends up being this number. This ends up being this number. And all they want you to do is do the summations. Once again, this just means find the sum of the first term. Here, find the sum of the first 2 terms. Find the sum of the first 3 terms, find the sum of the first 4 terms, and so on. That's all they wanted you to do in these problems. And they know you want a decimal number because up here it says round to 4 decimal places. So that's not too bad. And the same thing goes for this one. Find the sum of the series. And they're going to do this if n equals 5. By the way, if n equals 5, how would you go about, how would you go about if n equals 5, how would you go about finding the sum of the series? Anybody want to explain how they'd go about it? I mean, are you going to do 6, 0.8, you put a 1 in there, 1 minus 1. So that for n equals, this is n equals 1, you end up with 0. So that's 1, you end up with 6. So then n equals 2, you plug in 2 into this spot right here, 6 times 0.8, 2 minus 1, and you end up with 6 times 0.8, which ends up being, what is that, 4.8. And then you're going to add up the next one. Are you going to do this with all these numbers? You're going to be there all day. How would you do this? How else would you do this? Anybody have any ideas? What's the easy way of doing this?
That RN.
Yes, this is a geometric series. This is a fraction less than 1. So I want you, you need to be able to spot those out. This is a fraction less than 1, and I'm hoping they kind of show that in the answers, and they do. This is a fraction less than 1. So if we did that, then, I mean, let's just do 5 here once again. And remember, since I said, hey, let's write these down, I wrote them down. The summation of AR to the n equals A over 1 minus R. A is 6 and R equals 0.8. If you want to put that in fraction form, you can, R is 4 over 5. 0.8 is 4 over 5. So let's put A, once again, we said was 6. So for 5, n is 5. Is that A? Oh, this is telling you where the whole thing diverges. Oh, they want you to use a calculator. Okay. I was going to say, well, let's just see where the whole thing goes to. And they're going to show you, I think it goes to 30. So A is 6, the top number, and then 1 minus R, which you can put 4 over 5 or 0.8. And when you put this in your calculator, the bottom becomes 1/5. And then it flips to the top and it becomes 30. So this whole system, the whole summation diverges to 30, but they want you to put this in your graphing utility. They want you to put this in your calculator. I was going to say, how do they want you to do that? So it's approaching 30. So if you look at this, I mean, it's going to, this is going to approach 30 at some point. Has anybody ever done a summation on their TI-84? Let me grab my TI-84 and let's try to do that. So they want you to actually do it on your calculator. Where's my TI-84? I just have a calculator. Okay, oh, here it is. So we're doing, I'm going to write this summation down. Summation of 1 to infinity 6, 0.8, n minus 1. And we're going to go where n equals 5. They want to do the first one where n equals 5. I'm going to try to bring my calculator up here. Okay. Now, I've done this before. It's just, I haven't done this in a long time. Let's find how we do that summation. God, what was it? It was it math?
Yeah, you go to math and 0.
Okay, math 0. So if you go all the way down, there's 0, summation, math 0. Summation, and all our stuff is in there. And instead of n, let me try to focus it. So instead of n, we're going to put x, and x goes from 1, and we're going to go to 5 for the first one. And our equation was 6 parentheses 0.8. Raised to the n minus 1, wasn't it? Yeah. Raise it to the n minus 1, x minus 1. And then when I bring it back down, I should, I think I did too many parentheses. Hang on. Let's try this again. Math, and you can go up and to get the 0. You said math 0, right? Oh, there it is. Math 10. All right, let's try this again. X from 1 to 5. 1 to 5. I'm sorry, it'd probably be easier if I put it in my face so I can see it. And then we're going to do six times 0.8 raised to the power, I'm gonna raise the power in the parentheses and put the x minus 1 in parentheses like that. Okay, so I think that's how I typed it in. That's what we wanted, 6 to the 0.8 and raised to the n minus 1, which we're using x instead of n. And then when you hit enter, it gives you the summation. Everybody okay with that? You see, you hit math and then 0. You can just go to math and hit 0 and it'll get to the summation. And we got 20.1696. And let's see if that's what they got for the first one. Where's number? Well, they oh, is there? Oh, right here. Yeah, there it is, 20.1696. So we got the same thing. Then you would do the same thing. You would do the same thing, except instead of 5, you're going to put 10 up there. And then it'll give you the summation for the first 10. And then I think they're going to ask for 20, and they give you a summation for the first 20, and so on and so on. So that's I was going to ask, how do you do that? Well, you can do the entire summation using that formula, the R, the geometric formula. So that's kind of cool. And you can see if we go down to the actual answers, you can actually see how it gets larger and larger, and it's getting closer, and then it stops growing, but it gets closer and closer to 30. So it'll never go over 30 because that's considered almost like a horizontal asymptote, a limit, and it's going right up to 30, but it's never going to pass 30. All right. Number 3 is a good one. Number 3 is really good because the only reason, where's my drink? I'm sorry. Number 3 is really good because I've seen this question over and over. I don't know how to do this. Even with the help here, many students have a big problem with this. And here's the help. I mean, if we just look at this part, the question for students is, how do they get from here to here? That's what I'm asking you, because they don't tell you how they got from there to there. How do you think anybody have an idea how they got from this first summation to the second summation? They equal each other, but how did they get there? That's why I wanted to bring this up, because I think there might be one of these on the test in this section. By the way, chapter 9 is not on the test that you have coming up for test 2. It's on test 3 or whatever test we're on. So, and nobody knows how they got from here to here. We actually went over this, I think last week. They use partial fractions. So when you see a problem like this on the test or in the homework, question 3 is this one, you got to use partial fractions. 16 over n plus 2 can be rewritten as a over n plus b over n plus 2. Is a partial fractions problem. Multiply each numerator by n times n plus 2. And when I do that, if I multiply this by n times n plus 2, remember partial fractions, we just talked about that. And you multiply this by n times n plus 2. These all cancel, and you're left with 16. This cancels, and I'm left with a times n plus 2. These cancel, and I'm just left with b times n. And then you say, okay, what happens if n equals 0? If n equals 0, this becomes 0. If n is 0, I then put a 0 into here. and I get 16 equals 0 plus 2 is 2, 2a. So a equals 8. So there's one of the tops of the fractions, a equals 8. And then we're going to try it again. If I rewrite this, 16 equals a to n plus 2 and bn. And this time say n equals -2, because if I put a -2 in here, it turns to 0. And that's what we wanted to do for partial fractions. That turns to 0. If I put a -2 in here, I end up with 16 equals -2b. Divide both sides by -2 and b equals -8. So a equals 8 and b equals -8. And we're going to plug those back up here. So let me erase all this other stuff. And once again, a equals 8. We end up with 8 over n, and then b equals -8. So this becomes a -8 over n plus 2. So this becomes this, and that's how we got this right here. Oh, they factored out an 8. If you notice, they factored that 8 out right here. So if you factor the 8 out, you end up with 1 over n minus 1 over n plus 2. And that's how we got that right there. Okay. So just be prepared to use partial fractions. I mean, if you can't, you can plug infinity in here, and it's just going to give you 16 over infinity times infinity. It's just a big mess. It looks like it's 0. It could converge. More than likely, it does converge, but you don't know what it converges to. So it's a telescoping series, if you see. So then they went ahead. So, I mean, this was the hard part. This is the part I wanted to show you, that you had to use partial fractions to get to that part. Then you plug 1 into there. So you plug 1 in everywhere to n, and you get 1 over 1 is 1. And then 1 divided by 1 plus 2 is 1/3. Then you end up with plug a 2 in there. And a 2 in here, you end up with 1/2 minus 1/4, and so on. And if you look at this telescoping series, this cancels with this. And let's go to the next one. Now I want to go a little further. So we plug 1 in, n equals 1. We plug n equals 2. N equals 3. Let's plug n equals 4. The next one would be 1/4. And then if you put a 4 in there, then you get minus 1/6. And let's do one more. You put, next one would be 5, 1 over 5. And then you would get minus 1/7. And if you look here, so then the 1/3, let me change my color. This cancels with this. The 1/4 negative will cancel with this. The negative 1/5 will cancel with this. And it looks like they're all canceling if you look. I mean, the only thing that didn't cancel was the 1 and the plus 1/2. But then you have 2 more, if you look, you have 2 more numbers that didn't cancel. I mean, this goes on forever. No matter what n you put, if you said n78, you're going to still have 2. You're still going to have 2 n's that don't work. And if you look at this, this was the minus with the n plus 1, and this was the this is minus. Did you see this is 1, and this is 1 more than that, which is n plus 2. So you end up with these. So this is what the limit you end up with. I mean, it gives you a limit, the summation of a limit. When you plug infinity into here, what they want to show you is when you plug infinity into here, these turn to 0, and your summation just goes to 1.5. So it's 8 times 1.5. This 8 times this 1.5, and 8 times 1.5 equals 12. And they show you the summation goes towards 12. So I mean, that once again, that's telescopic. And the main thing I wanted to show you is that you might have to use partial fractions sometimes. And I'm not a big fan that they only showed 3. I would say take it 4 or 5, take it 4 or 5 out and look at what's canceling and how much is canceling. You might have to take it 6 or 7 out, and you'll see what's canceling and what's not canceling. You know, you take it 5 out, and I showed you that 2 things weren't canceling. But when you put infinity, when n gets to infinity, 1 over infinity, this reaches 0 and this reaches 0. So this is what we're dealing with, 1.5. And then we had to multiply it by 8 because we factored in 8 out at the top there. So 8 times 1.5. So this sequence, this series does a summation up to 12. And that's the hard, I'm going to say that's a hard problem just because of the partial fractions. Just because of the partial fractions. And I always recommend, don't just take it like they did to 3. Check it out more, and you'll see. It'll look. I think it looks easier, and understand what's canceling and what's not canceling. Okay. Let's see what else we got. Find this summation. So we're just using that formula that we had. That's all they're doing. And once again, the formula, if you haven't written it down, you better write it down now. It's a over r to the n power equals a over 1 minus r. That's supposed to be an a. It looks like a 9. 1 minus r. And in this case, r is less than 1, so r is 2/3, and a is 7. So you can find the summation by just plugging 7 in the a, and then 2/3 here. The bottom becomes 1 minus 2/3 is 1/3. 7 divided by 1/3 is 21. And there's your summation. From 0 to infinity, it goes to 21. See what else we have. Find the summation, sum of the convergent series. Oh, interesting. Now, how would we do this? How would we do this if we, they didn't give us the information. So that's kind of interesting to see this. It's going to be a summation. And the first number is 0. It doesn't even tell us that it's geometric. But since we end up with fractions, I'm going to say we probably have to know somehow that it's geometric somehow. And if it's geometric, then r has to be less than 1. Or should be less than 1. The fractions are getting smaller and smaller. So no matter what you do, when you put 0 in here, this is going to turn to 1. Any number to the 0 power equals 1. So in the first number, we know that's going to be a. A equals 2. So we know we're going to be stuck with 2 and then some fraction. The second, if we have 2 and the second fraction is going to be 1/2. We're going to, because the second number, we're going to put 1 into n. So what fraction to the 1 power turns this into 1/2? And the only thing that turns 2 into 1, it turns 2 into 1. Half of 2 is 1/2. So that's why we put the 1/2 in that spot. And then we have the end. Then we can put the end there. Then you can try the next one, the third term, which n equals 2, which is 2 times 1/2 to the second power, which is 2 times 1/4, which equals 1/2. And we got 1/2 there, and so on and so on. Yeah, try that, and you see the fractions are there. So use that geometric series and start off with n equals 0. So you'll be able to spot A. And then once you have A, you have a fraction here, and you're going to have a 1, and the second term equals 1. The only way to get 1 there is if you put a 1/2 there. So then you have A, you have R, and then you can find the next. Oh, now that you have A equals 2, R equals 1/2, then you plug it into the formula. A over 1 minus R. A is 2, 1 minus R is 1/2. 2 over 1 minus 1/2 is 1/2, and that equals 4. There's our summation. It's actually kind of fun trying to solve some of these. It's a little challenging. This is kind of cool also. I like the help that they gave here. If you just type in sine of 3, I'm just going to mention, hey, if you just type in sine of 3, if you look, sine of 3 is less than 1. So it's a geometric series that converges, and it's less than 1. So once again, if you look at that, R equals the sine of 3 in this series. R equals the sine of 3. So the summation of this equals, this is kind of cool. But n starts at 1, but we need n to start at 0. So if you put a 0 in here, you end up with, I don't know how that, this is a little interesting. They're showing you that you can change that 1 to a 0 by having sine 3 here. We know that if I have a 1 here, I'm not sure. I don't know if anybody sees that. I don't see it. They changed this from 1 to 0, but they put the sine 3 in front. I don't see that mathematically. I don't see it. I'm sure it's there, but I don't see it. They're saying A also equals the sine of 3. So, I mean, that's A and that's R. So they're showing that A equals the sine of 3 and R equals the sine of 3. I'm not sure. Does anybody see how they changed this summation from 1 to 0, but they bring because 0 ends up being 1. I don't see it. Oh, let's go to watch it. Well, I'm not going to watch it. They'll tell you how in this watch it. There we go. Maybe that's why I put it here. So I'm going to watch it at the end of class, and then I'll know a little bit better. But so it has a watch it. So that's I'm just if it has a watch it. I just want to see if they explain it. I'm sure they're going to explain it. I won't. I wanted to try to get through it a little quicker than that, just to see it. Yeah. Yes. And so I don't know if he explained that, but watch that video and that hopefully that explains it. I'm going to watch the whole thing after class. So that's good that it has a watch it, because I'm not exactly sure how they get that. I mean, that's from algebra. There's some kind of algebra property. If we go back to the algebra book, there's some kind of algebra property that lets us do that. You can take it back one notch. And I'm not exactly sure which property or rule that they're using. So hopefully I can see that. All right, problem 7 is kind of cool also. It's a geometric series and it starts with 0, so we're good to go there. If you look at it, 0.4444444 goes on forever. Write this as a repeating decimal. Write the repeating decimal as a geometric series. So we want to put this 4 here first, and that will be our A, 4/10. I mean, that's that first 4 if you look at that, because you're going to have a geometric series. You're going to have, let me erase this first. You're going to have an A, then you're going to have some kind of fraction R, then you're going to have an N power. And if you put a 0 here, this turns to 1. So the first thing, the first number in this series is 4. So you're 0.4 there. So that's what A equals. 0.4, which is 4/10. Or you can put 2/5, but I think they wanted to put 4/10 so it would look easier. You realize that there's a 4 there. Now, if you put a 1 here, you have the 0.4, but you need another 4 after that. For the second one. So if you put 1/10 here, then it's going to be 0.4 plus 0.04. You see, that's the second. This is n equals 0. This is n equals 1. And then if you put a 2 here, 1/10 to the second power is 1/100. And if you put a 2 here, n equals 2, you get 0.004. So this goes, it just keeps on going. The next decimal place, they put a 4, you add a 4 to the next decimal place. That's what you're doing. You're summing these all the way to infinity. You're just putting a 4 in the next decimal place. So this is what you would put in summation as n goes from 0 to infinity. This is what you would put right there. If you see that, you're starting off with a 0.4, then you want a 0.04 added to that, then you want a 0.004 to add it to that, and that's what you get. Now, once you have that, you have A and you have R, and you just plug it into the formula. A over 1 minus R. A is 4/10. R is 1/10. You put this 4/10 divided by 9/10. And when you flip it and all that, you end up with 4/9. flip it and multiply it, you end up with 4/9. And that's where the series ends up, the sum of the series ends up at 4/9. So that's kind of interesting. The thing is, look at this problem as a geometric series and look at the A times R times N. You know, when you start off with a 0 in there, and then that gives you the A, the first 0.4. So we know A equals 0.4, which is 4/10. And then we have to have the next 4 after that. All right, that's kind of cool. And 8 is very similar to that one. 9, wait, was it 9, 10? No, it wasn't 9 and 10. I wasn't too worried. Determine the convergence and divergence of the series. They already show you. If you look at, if you just put like the natural log of 1 on your calculator, I don't know, yeah, natural log of 1 equals 0. Try the natural log of 2. You know, the natural log of 1, you end up with 0 here. Try the natural log of 2. If n is 2, the next number, you get 0.69. Then try the natural log of 3. Natural log of 3 is 1.09. If you look, they show you that n is larger than the natural. The top is larger than the bottom. So if you look, this number isn't going to 0. 2 divided by 0.69, and then 3 divided by 1.09. If you look, the number is not, these numbers are not going to 0. They're not going to 0. It says they do not approach 0 as n goes to infinity, so it diverges. I'll let you take a look at number 10 itself. I think they want you to write that formula there. Once again, I'm not too worried about that problem. But 11 and 12, these are algebra problems. These are from college algebra. And there's some formulas that you need to take a look at from summations. And so for 11 and 12, I want you to watch it because they have those formulas. And I would, and I looked in the PowerPoint, and I didn't have those formulas written down in the PowerPoint, and they're not even, they didn't even write those formulas in the book in this section. These are algebra problems. So don't use your calculator to find this summation. I want you to do the watch it and write down those formulas that they have in the watch it. So do both of these, watch both of these watch its and write down the formulas. While you're watching these, because those formulas come from algebra and they didn't even put those formulas in this book. So to find these summations. So if you remember your algebra and these summation formulas, maybe these formulas will pop into your brain again once you see them again. But I do want you to write those formulas down and have them written down just in case you have one of these on the test and you have to show your work where I'm asking for the formulas and not just, I mean, I can go from 2 to 6 and just add them all up. But I'd rather you look at the formulas on how to do them in case I say, hey, I don't want you just plugging it in and adding it up. I want you to use the formulas. And they do the same thing here. They want you, you're going to have to find out what n this is, you know, and this is, if you look at it, this is N1, N2, and 3. And you have to figure out what N this is. And there's a formula for that. And you get that from watching this, this Watch It. Okay. Let me see. I think that was the end of that section. Let me hit stop record.